Thank you for all. What do we got here? 16 people. All right. So as a lot of you know, you see that there is a test this Friday. I thought about it a lot, and you'll just basically be given a certain amount of time, and it'll be due that day. When you wake up in the morning, it'll be uploaded at the time your class starts. If you should know the schedule, but I'll show you guys anyway. Share. Wait, which screen am I trying to share? Oh, this one. So this Friday, obviously for second period, 9 o'clock in the morning, 9:55, 10:50. It'll be posted in those respective times. It's going to be due in the afternoon. If I had to pick a time now, I think 5 p.m. is pretty fair. I'm only giving the fact that I don't know who has access to a computer or computer access all the time, but you'll pretty much have the day to do it. And I can't really stop you how you take it. So, but with that being said, it'll be graded pretty harshly. I don't know if that's the right word. As in, we clearly say that if you don't show work, you're not going to get any credit. Like typing in the correct answer without showing anything. So some of the best ways to do it is to just the most low tech version would be to copy the whole thing down by hand and then just do it on your notebook. If you've got access to a printer, great. If you wanted to type in your answers, that's also good too. The only challenge is being able to show work when it says to show work. And for each problem that needs work, it specifically says show work in bold that you need. Okay. I'm going to open the floor to any questions before I just break down everything that will be on it. For you wonderful 18 people, you will get the advantage of knowing exactly what you need to know. Open the chat. How long is the test? It is 2 pages. 1 full page and then a second full page. That it? Okay. So you guys were given a review assignment to do this week, and we assigned it earlier than usual. I figured we just break that thing down. Whoa, someone turned it in. Wow. Okay. Okay. These first 6 problems on here, those were all what we've done in the past 3 weeks. So the biggest, whoa, what the heck? Oh, it's upside down. So the biggest thing with all of these for the first 3 of these, we talked about it. Factor, cancel, then multiply it out if it's possible. Do not ever can't. Is each problem still worth 5 points? Yes. So, sorry. Let me also. So let's say the test is worth 30 or 50 points. I don't remember the points. So it's still going to be plugged into your remote learning section. If you haven't noticed, we should talk about that real quick. I think only Hazel and Rachel saw this. The breakdown of the grade, if you haven't noticed yet, because we changed that too. And I kind of didn't tell anyone yet because I just wanted to see how the grades were going. And actually, I liked how the grades were going, so I kept it, and I haven't talked about it yet. Scores by category. Here we go. Okay. If you haven't noticed yet, our new grading system, we took out final. Everything that will be done remotely is going to be plugged into distance learning. That's encompassing the the final third of the whole class, of the whole school year, 30%. Everything else encompasses the remaining 70%, but nothing else will be plugged in for anything here. Everything we do gets plugged into distance learning, whether they'll be tests or homework or assignments or whatever gets plugged into here. You will not have a final. Now, there will be something at the end, but it won't be a final test. Like it might be a project or a big assignment. I don't know, but Ms. Fishberg and I still need to talk about what that is. So each assignment has been worth 8 points because it's roughly 2 homeworks. Okay. Now your tests will be about 30 points. That's, if you think about it, that's roughly 3 assignments worth. Okay, sorry, time out. Someone named Jeff Exotic is trying to get into this meeting. I'm afraid to hit admit. Okay, who is that? Jeff Exotic. Who are you? Alex, okay, is it? Okay. Okay, thanks. What would the math project look like? I know it could be like a graphic art project. That's one thing we've done before. But I don't know. Okay, anyway, so it being worth 30%, that's a huge thing because what you have seen is if you've been doing all the work remotely, your grade probably looks okay right now because you've been doing everything, and it's bumping your grade up because this is worth almost as much as tests used to be worth. It's actually worth equal to our first test, which this used to be 50%. This first test used to be 60%? I don't remember. It used to be 50%, I think, and it was really bringing a lot of people down. When I adjusted the distance learning to be worth more, a lot of people got bumped, especially if you have been doing this. If you've missed assignments from our remote learning, your grade probably went down a lot because it's worth a lot more. So I'm still being flexible, as in if there are things that you did not do yet, I can still grade it for some credit. So you don't want to leave blanks for your any remote assignments. I know we're past no pass. Okay? You should still try the best you can because your final percentage is still going to determine what class I can recommend you for next year. So that's still the leverage I have, and the leverage you have to at least still try your best. Whoa. Oh. Oh no, public safety alert. Oh, okay. This is old news. Okay. Okay. Any questions about the grade breakdown before we get into reviewing what you need to know? Okay, if you had just gotten here, we just discussed the new grade breakdown, and we also just discussed the details of this Friday's test, which I'll talk about again. Oh yeah, no, we talked about showing work. The showing work is going to be even more crucial. Typing in the correct answer nets you 0 points, for example. Okay, cool. Thank you. Awesome. Okay. Let's go back to this test review. So this the test itself is about 2 pages. This review assignment is a lot longer than the actual test. So definitely you guys need to do all of these. Why is my marker being that? Let's use red. For these first three, factor, cancel, and multiply. Actually, it applies to these two as well. So I will do 2 of them. No, I'll do 3 of them. This first one, we need to factor everything because we hopefully can factor everything, and we're hoping things can cancel out. I'm not here to teach a factoring lesson. However, if you ask me later, I can teach you how to factor again. But because I'm good at factoring, I believe this is 3x and x, and this is going to be plus 1 minus... Oh, no. Wait. Uh-oh. I can't... I forgot how to factor. Hold on. Uh, 3x, and this is x, is... I think it's 2 and plus 2. Yep. And the bottom is going to be x minus 2, x minus 1. I know. How do you know it's 3x and x? 3x times x is 3x squared. This times this equals 3x squared. Plus 2 and negative 2 is positive 4. And it works out. When I multiply it out, I get negative 4x in the middle. I mean, you have a lot of time to practice your factoring, even when you take the test. You still need to show work, though. Again, I haven't canceled anything yet until I am done factoring. And remember, those parentheses can be canceled. This is a big no-no. Don't do that. Don't also do this. Don't also do this. Factor completely and then cancel wholeheartedly. We're thinking of these minuses and plus signs as handcuffs. How do you know? Will we have to worry about decimal numbers, though? No. I don't know what you mean, but no. X minus... What was this again? Plus 1? Oh, minus 1. Okay. Cancel, cancel. I'm left with 3x plus 2 over x minus 1. This cannot be taken any further. This is all there is to it. Okay. Remember, also, canceling can only be done crosswise or up and down. Never straight across like this. Okay. Going down over here, this is division, which means we'll also flip. So from your middle school days, we would copy dot flip. And then factor. And then cancel. And then multiply. Over here, I'll do the same thing. Copy dot... Oh, no, I didn't copy it. Copy dot flip, and this has been flipped. Now we still need to factor here. I haven't factored yet. This is x plus 6 squared. That's already factored. This is just nothing to factor here. This is nothing to factor here. However, the top here can factor. This is x squared minus 12. This is x minus 12, x plus 1. Okay. Now, if you... I saw some errors in your homework when you guys did this. Okay. You have x plus 6 squared and x plus 6 up here. That's one x plus 6 canceled out. And I would cancel out one of these since there'd be 2 of them. One of them gets canceled, and you're left with 1 left. I'm not going to write out x plus 1, x plus 1, x plus 1 here, because I could see there's one of these x plus 1s here, and there's 3 of them. So if I cancel this out, all I'm going to do is cross that out and turn it to a 2, because there's now 2 left. So now that we've canceled everything, it looks messy, but we're just going to write out whatever's left. What's left is x minus 12 on top. I'm just looking by. I canceled everything else. On the bottom is x plus 6. And on the also bottom is x plus 1 squared. And I look closely, nothing else can be canceled. This is totally different. This is adding. We need something called the at least common multiple. Any questions on the first things I gone over, though? Because this one needs extra attention, this last one. What about the excluded values? Excellent question. So, excluded values for this one would have been 2 and 1. The reason why it's 2 and 1 is because those will make the denominator equal to 0. I could tell because if I plug in 2 here, it makes this 0, which makes the whole thing 0. If you plug in 1 here, it also makes it 0. Makes denom equal to 0. The reason why we exclude them is because it would make it undefined. Any other questions? Why 2? Again, if I plug in 2 here, even though it gets canceled, it's still considered an excluded value. 2 minus 2 is 0. 0 times whatever gives us 0. Even if it gets canceled, it's still an excluded value. So in essence, you would tell me the excluded values before you cross anything out. Okay, I'm going to clear all this unless someone doesn't want me to. Okay. Oh, I'm not going to clear all of it. I'm just going to zoom into this problem here. Okay. This one's going to take some extra care. So we're still going to factor here, but I'm only going to factor the denominator. Because to add fractions, they need to have the same denominator. Right now they don't. This is x squared plus x minus 2, x plus 2. But we want to make it so that they have the same denominator by finding out what this LCM is. To figure that out, I need to factor out the bottom here, which is x plus 2, x minus 1. And I look at it, and I go, whoa, this has an x plus 2 and an x minus 1. This does not have an x minus 1. So what we're going to do is multiply the top and bottom here by by x minus 1 on top and x minus 1 on the bottom. Because now what happens is this now has the same denominator as the other one. This is still the same. We're not going to multiply the top by anything because the denominator didn't need to change. But since we're multiplying x minus 1 over here to that, to the 1, this becomes 1 times x minus 1, which is just x minus 1. Now that they have the same denominator, I can now add them. When you add fractions, you are doing nothing with the denominator afterwards. But we're adding x plus x minus 1, which gives us 2x minus 1. And this is the final answer. And looking closely, nothing can be canceled. This 2x is handcuffed to the minus 1. I'm not going to cancel anything individually there. Any questions? You will get 2 of these on your test. I'm not going to tell you which ones. But one of them has to do with adding and subtracting. Okay. Any questions? Okay. Moving down. We probably should review this. Divide. Notice this question does not say long division, polynomial division, or whatever. For our class, we learned how to do synthetic division. Since we're using x minus 3, it's been so long since we did this. Since we used x minus 3, 3 would be the number we were putting for synthetic division. Up here would be the numbers of the coefficients of this polynomial. But be very wary. I'm going to write 1 x to the 4th minus 2 x to the 3rd, 0, and then 1 minus 25. Why was it 0? Can anybody quickly tell me why I put a 0 there? Yes, there is no x squared term. It's missing the x squared term. We have to account for that slot. So then I drop the 1, 3, 1, 3, 3, 9, 10, 30, negative 5. Wait, did I do something wrong? 1, 3, negative 2, positive 1, 3. Oh, 5. Okay. So our final answer here would be now 1x to the 3rd plus 1x squared plus 3x plus 10 with a remainder 5. And you also have to remember what happens if the remainder was 0, but we'll get to that in the rest of the problem. List all possible roots. This is on your test as well. Listing all the possible roots is pretty simple. It's taking all the factors of the last divided by the factors of the first. In other words, everything that goes into 25, that's plus or minus 1, plus or minus 5, and plus or minus 25. And I'm going to divide it all by the factors of the first. The x to the 4th, well, it's the factors of the coefficient, which is 1, which is just plus or minus 1. And it's just basically taking these numbers and dividing them all by 1, and we get plus or minus 1, plus or minus 5, plus or minus 25. All of these could be our roots or zeros. Plus or minus 1, plus or minus 5, plus or minus 25. Okay. All the numbers that go into 25, you have plus or minus 1, plus or minus 5, and plus or minus 25. Those are the only numbers that go into 25. That's why I say factors of the last number, this number here. All the factors of the first number, which is the coefficient 1 right here, is just 1 and negative 1. And so I'm taking all these numbers and dividing it by 1 and negative 1, and we just get the same exact answers again. If there was a 2 here also, we would have to take the same numbers and divide them all by 2, which would now add 1/2, 5/2, and 25/2 to our list, but there isn't a 2 here. Go ahead.
Okay. For this kind of problem, would it be possible to also
Still
do
can't hear
a
you.
fraction as a way to divide it? Like x to the 4th minus 2.
Oh wait, I have to
over x
unmute you.
minus 3.
I'm sorry. Where are you? Tens or call saying.
Hello?
Where the heck are you?
Hello?
Oh, I unmuted you. Can you talk?
Can you hear me?
You can hear her? How come I can't hear her?
You can't? Is your Venus connected to computer audio? Wait.
I don't know why I can't hear her. Yeah.
Oh no. Okay.
Okay, talk again. I'm listening to you through my speakers.
Can you hear me now?
Yeah, but I don't know why not through my
Oh my
headphones. Go
god.
ahead.
That sucks. Okay. My question was basically, um could we solve this using like a fraction instead of doing like synthetic division? Or oh wait.
No. If
Okay.
you're trying to divide them, no.
Divide it. No, yeah, I get what you mean.
Because you don't know how to factor this top here.
Oh, you're right. Yeah, never mind.
Okay. That's so weird. How come I can only hear her through my speakers?
I think your thing's broken.
Maybe. Anyway. Oh, it works now. Okay, cool. Okay.
Bye-bye.
Let me get through. If x minus 1 is a factor of f of x, finding all of the roots. This tells us a big thing. If we know x minus 1 is a factor, it tells us if I do synthetic division with the same numbers, this is going to be 1, this is going to be 1, this is going to be -1, this is going to be -1, this is going to be -1, -1. Oh, wait, how come it's about to not work? Hold on. It's supposed to work. Oh, no, I used the wrong one. It's this one. I have to use that one. Sorry. Okay, 1, 1, 3, -1, -3. Okay, that's 1, 3, 6, 6, -5, 5. Whoa, wait a minute. What the heck? It should work. Oh, wow, I'm dumb. Okay, let's do that again. Oh, goodness gracious. 1, 1, 4, 4, -3. Oh, +3. Wow, Mr. Vernes is forgetting how to add everything. Okay, so we get a good remainder 0, which is important because that tells us it is indeed a factor or root, and that's what should be true. So find all the other roots. Now, the remaining 3 numbers gives us x squared plus 4x plus 3, which tells us that we can use this last thing to find the other roots. You can either factor this or quadratic formula. It's factorable, so I'm just going to factor it. So then it says find all the other roots. Our roots are -3, -1, and the original one that we got given to us. Okay. Give a rough sketch based on your results in part B. Well, we learned how to do this. The degree is 3. It tells us that it's going to, well, first we know it crosses at -3, -1, and +1. And if you remember the shape of which something that is degree 3 looks like, it starts down here, goes up here, and goes here, like so. Remember, odd, the man does this. Even. Looks like that. Okay. This is basically the same question. You have to count the degree. I'll make notes here. Count. I'm gonna post this. Don't worry what I'm doing now. I'm gonna post this. This is basically the answer key. Count the degree, and then look at that. Ooh, compound interest. Okay. It's all about that compound interest, especially continuously compound interest. Let's invest $10K into the bank at 5%, 5.5% continuously compound interest. That was on homework. The formula for this is A is equal to P E to the RT. The E is a number like pi on your calculator. P is the initial amount. R is still the rate. And T is still time. E is the thing you find on your calculator. It's a number that represents as if you compounded it infinitely. How much money will be after 10 years? Well, what we're going to do is plug in 10,000, type in E to the 0.055 to the times 10 power. Yeah, you do. Do you have a smartphone or access to a? You can also Google scientific calculator. Let's do that. Let's Google online science. For those of you who do not own one, hey, Google has one. There's the E button right there. So we're gonna type in 10,000 times E to the what was it, 10 years? You have permission to use any resources at home, essentially. I don't think that's right. I think I gotta do it backwards, like PEMDAS. We have to do 0.055 times 10. That's 0.55, and we're gonna go E to that power. And then times that by 10,000. I get $17,332. So I basically did this part in my calculator first, and then E to that power, and then times it by 10,000. I basically did PEMDAS in order of operations. 17,000. I already forgot what it was. 17,000 what? $332. Will I double my money in 20 years' time? Well, we can just check. If I instead put 10,000 E to the 0.055 in 20 years, is it going to be 20,000? Question mark. And then I'll show you guys to do that again. So again, I did 0.055 times the time, which in this case here would be 20. Then I'm going to go E, and this button right here, XY, it means to E to the or exponents 1.1 power, and times this by 10,000. I think we're definitely going to double our money. Yes, we got $30,041. You'll triple. It's $30,041. I need to double my $300 investment that will be compounded monthly at the Superbank at 5% interest. Like, how long will it take? So this is compound interest. This is the formula. 1 plus R divided by N to the NT power. R is still the rate. N is the number of compounded per year. And T is time. And P, you guys know, is the initial amount. So this is 300, and we want to double this. So I'm going to set it equal to 600. 1 plus 0.05 to the divided by its monthly interest. So that's 12 times a year, 12T. So essentially, you would need to solve this using logs. Yes. No, NT, N as in nectarine, NT. Okay. Is there any questions on anything? I'm not gonna finish it because I don't know if that's on the test. Solving that with logs, I don't think so. I know this isn't on it. I know this is on it. The continuously compound interest, but this solving logs thing. Just look at the answer key. Someone's about to talk. Okay, never mind. I'll finish the answer key. I'll upload it tonight so you guys can take a look at it. But I'm giving more detail to the ones I know that it's on there. This is on there. Graphing with inequalities. Remember, this is the thing that requires shading. Someone stop unmuting yourself, whoever is that. Okay. You guys should know the first one. That's an absolute value. Good gracious. Okay, let's do that again. Okay, there were several ways to decide which side to shade. It's going to be up here or down here. I like to just look at this greater than, which means above. I'll do the circle in green. This is a circle. This is, of course, absolute value. This is a circle of radius 5. And it's a dashed circle. And looks like less than, which means under or inside the circle. So like this, and then in a different color, the darkened area would be right here. So keep in mind that this would be inside, no. Above. But also the other way to do it is to plug in a point like 0, 0. And then plugging in and see if it satisfies the inequality and decides which side to shade. This one here, I should need to go over too much. Wait, why is it? Oh, okay. These problems here, just pick any 4, really. But there's really nothing much for me to go over down here. Going back up here, how much time do I got left? Okay. Shouldn't have to go over this one. I could just do it real quick. 2, that's 27 times 2 is 54 minus 5 is 49. Just plugging it in. Ooh, and x of f of x equals 11. Not plugging in 11. This is 2x to the third minus 5. This is 16 equals 2x to the third. That becomes 8 equals x to the third. X is 2. Inverse. Okay. Starting off with the x, we're going to go the opposite direction here. The last thing they do is minus 5, so then I'm going to add 5. Then they times by 2, so I'll divide the whole thing by 2. Then I'll take the third root of that. I know I'm going through this quickly, but finding the inverse should be something that you should roughly know more than the other things I want to spend more time on. Would it help if I had an additional office hours on Friday? Like before the before you have to turn in the test. That's kind of weird. Why not? I'll post it, and yeah. Okay. This is the new stuff. This is not on test. I'm not going to go over this one. This one is graph the points. We provided a graph for you. Well, positive, negative, negative, positive, positive, negative. This is the y-axis, x-axis, and z-axis. So it's kind of weird, but we will know whether or not you did this correctly. To graph 2, 3, negative 4 means I go to along the x-axis positive to 2. So I'd mark it 2. And then I'd go along the y-axis to positive 3. And then somehow I have to go down to negative 4 on the z-axis. So 1, 2, 3, 4. That's roughly where the point is. So one way to do this is to draw the path. Here, here, and then down here. We will know if you're correct or not. What's a z-axis? The z-axis is the three-dimensional going up and down. So if we have 2 dimensions, that's x and y. There's watch the YouTube video too on the lessons there, Rohan. It's also there, but I'm showing you now. So if you look at the corner of a room, imagine this is a corner of a room of your house. The z-axis would be the one going to the ceiling. This is the one coming at you, the y-axis, and the x-axis is the one going to the right. And z-axis means going in elevation, y going this way, x going that way. So here's the point, 2, 3, negative 4. Now, to graph an equation, you need to find the x and y and z intercepts. Okay? To find the x-intercepts, we're just going to cover up. I'm going to literally take my 2 fingers and cover the y and the z. And when I do that, I get 2x is equal to 12. That tells me my x-intercept is 6. So that is, this is already wrong. Hold on. Oops. Okay. This would be 6, 0, 0. Over here, take your 2 fingers and cover the 2x and the 4z. You get negative 3y equals 12. That tells us my y-intercept is negative 4. So 0, negative 4, 0. Finally, for the z-axis, that'd be 0, 0, 3. So the idea is okay, there's my weird looking 3-dimensional graph. 6, 0, 0, 6, 0, 0 is right here. 0, 0, 3 is up here. No. These are 3 separate points. 3 separate intercept, y, this is the x-intercept, y-intercept, and z-intercept. And negative 4, 0, negative 4, 0 is down here. Okay. When I connect all 3 of these, you should see a 3-dimensional triangle floating in space that represents the plane of which this equation represents. Plane. This is all in a lesson video we did. The most the most recent one covers this. Okay. Ooh, difference between a permutation and a combination. Easiest way to do this is to break it down. Yes, order matters. Order doesn't. But they both have no repeats, basically. We had a whole homework assignment on that, on deciding the difference between them. So we're gonna give you situations like organizing magazines on a coffee table. If you have 10 magazines to choose from, and you want to organize 4 of them on your table, you have to decide of which the order of how you place them on your coffee table would matter or not. In that case here, that wouldn't matter. So it'd be C 10 4. Remember, this is choices. This is decisions. Out of 10 choices, you're making 4 decisions to make. And it works for P too as well. I don't think you need to know the formulas. I think we're accepting this as an answer. But either way, you can plug that into an online calculator and get an answer for that. I wanted to go over here. I want to cover this before we are done today. I'll do another alpha hours. I realized I didn't really go over as much as I wanted to. Okay. Ooh, bias questions. That's not on there. Yeah, Ms. Fishberg didn't even finish the question. Anyway, that's not on there. Bias questions and survey stuff, it's not on there. But this is on there, what I'm highlighting right now. So use Pascal's triangle to multiply x minus 3 to the 4th power. You do not want to sit there and write x minus 3 times x minus 3 times x minus 3. We need Pascal's triangle. And you need to know which row to use. I'm using this row, row number 4. 1, 4, 6, 4, 1. Now, using the theorem, there's a pattern this follows. This is x to the 4th times negative 3 to the 0 plus x to the 3rd times negative 3 to the 1 plus x squared negative 3 to the 2 plus x1 negative 3 to the 3, finally, plus x0 negative 3 to the 4th. If you never caught on, the first term, the x and the x, starts with the 4th power. And it counts down, x to the 4th, x to the 3rd, x squared, x1, x0. The second term, the negative 3, starts with 0. And it counts up, 1, 2, 3, all the way up to 4. We also need to add these numbers right here. I'll pick a better color so we could see it. Let's use yellow, orange. 1, 4, 6, 4, 1. And that would be how it is expanded. However, to receive full credit for this, you still need to clean this up and simplify it. We've decided that we want the full-blown, on a regular math 3 test, if this was in class, I would accept this as full credit. But since you're at home and you have more time than usual to do this, I want the full-blown simplified answer of this. This would net you 3 out of 5 points if you presented all this. I want the whole thing, though. So you have to take each term one by one and multiply it out. This is 1x to the 4th times negative 3 to the 0. That's 0. That's 1 times 1, x to the 4th, plus Negative 3 to the first is 1 times 4. That's negative 12x to the third, and so forth and so forth. I'm just going to do the rest of this quickly. 54x squared. I don't know what 27 times 4 is. $108. Thanks. And then the last one is just, I think 81. Yeah, 81. Okay. So let's zoom out a bit. If you take a look at all the work I did, that's basically what you'll be tested on. I'm going to upload this later tonight, and with the full answers of everything else. But I would take this as a reference